The Law of Sines, part 2, a little more difficult here. So we're going to see an example, and you'll see as we go, you might think, well, all of these problems got to be identical. You'll see how this one differs a little bit. So we've got one more example for you. Uno más. That means one more for you non-French speaking students. So we'll take a look here at example number 2. Here I'm not given a picture. Here I'm just given 3 pieces of information. The measure of angle C is 145. Side length of B is 7. And side length of C is 33. And I got to solve the triangle. Solve triangle ABC. Well, the first thing I would do is sketch a picture. Some serious importance here to sketch a picture. And I see that angle C is 145 degrees, which is quite obtuse. So I don't know exactly how to draw this picture, but I am going to make an obtuse triangle and make sure that obtuse angle is angle C and label it 145 degrees with a 33 unit side length opposite that angle C. And then angle B and the side opposite it has got to be 7, leaving angle A and side length A. So now I've got a triangle that I've got to solve. Again, 3 pieces of information provided, and hopefully that's going to provide me enough information to get home. Some of you will attempt this problem on your own. I would tempt you to do that right now. I challenge you to do that. See if you can solve that triangle, and I think you'll run into a roadblock that you may or may not be able to hurdle. So let's take a look. Here's our skeleton for the law of sines. Let's plug in what we do know. Sine of A over A equals sine B over 7 equals sine 145 over 33. I see immediately the power fraction is that third fraction, sine 145 over 33. There's 2 pieces of known information. And I'm going to set that equal to the second fraction. At least I have 1 known piece of information there. I've got 3 out of 4. That's what I need. So here's the proportion. I evaluated the sine of 145 in my calculator in degree mode and got 0.5736. And now it's time to cross multiply. Here's 33 sine of angle B equals, the multiplication here yields 4.015. Now to get sine B by itself, first I got to divide both sides by 33. In doing so, the 33's cancel. I'm left with sine B equals, and on my calculator I go 4.015 divided by 33. I get 0.1217. Now here's where that roadblock is. The sine of angle B equals 0.1217. How do would you have that? The algebraic equation? Would you? How do you get B by itself? Do you divide both sides by sine? That seems a little awkward. I don't know if that's the right move to make. Yeah, so here's where the roadblock exists. Some of you have been exposed to this and some of you have not. In order to undo sine, what you've got to do is take the inverse sine of both sides of the equal sign. You can find the inverse sign on your calculator, that sine to the negative first power, by hitting your second button and then the sine button. You'll see it written in my calculator. It's written on your calculator in the same color as your second button, all right? And right above the true sine button, you'll see sine inverse. Anyways, when I take the inverse sign of both sides of the equal sign, what that will do is undo the sign that you have there and leave you isolated with angle B. So when you take the inverse sign of the right-hand side, the inverse sign of 0.1217, you'll get about 7 degrees. Something serious close to 7 degrees. So now I know angle B is 7 degrees. And I'll label that on my picture. Awesome. I've got to solve for the entire triangle. Now here's the second trick of the trade. Some of you looked at that first fraction, the sine A over A, and it scared you a little bit. You're like, I'm not given a single piece of information. How am I supposed to do that? Well, now that you've done some work and solved for angle B, you've got 2 out of 3 angles in that triangle. That allows you to realize the triangle angle sum has got to be 180. This allows for you to solve for angle A. And without doing this, you are stuck. So I know that this is 28 degrees. And now I know angle A. You should be in pretty good shape at this stage. That's serious important if you don't catch that. So two kind of tough steps here. The inverse sine step was semi-tough. And if it didn't occur to you to write in the measure of angle A there, you're spinning your tires. All right. So I'm going to replace the sine of angle A with a sine of 28 degrees there. And now I know that I'm going to be able to use my power fraction and that first fraction in order to solve for the side length of A. So I've got sine A over A. Here's all three fractions, but I'm going to use the first and the third as pointed out by those red arrows. Rewriting this, sine of 28 over A equals sine 145 over 33. We've been down this road before. We're cross multiplying here and getting A times the sine of 145 equals cross multiplying here and getting 33 sine 28. Dividing both sides by sine 145. The sine of 145 will cancel, isolating side length A. And when you do the math here, you'll get very close to 27. So I like to make a list here to make sure I've got everything. To solve the triangle, I've got to find angle A, angle B, angle C, side length A, B, and C. So if you make a list like that, you know that you haven't missed the boat on anything. And here are the measures that you have found. So a little bit more difficult problem here associated with the law of sines. And you can see how you get home. Now you might be asking yourself one question. What kind of arrangement do I need to look for here to do the law of sines versus the law of cosines? Well, the law of cosines, if you have given information that looks like side angle side, that points to the law of cosines. Okay? If you have a side angle side situation, the law of sines you'll try and attempt and it won't work out for you. If you got an angle side angle scenario or an angle angle side scenario, lean on the law of sines. A little trick of the trade here. So if you get a worksheet that says use either the law of sines or the law of cosines to solve each triangle, now you've got to make a determination on which one to use. And a quick glance, are you looking at side angle side? That yields law of cosines. Or angle side angle, angle angle side, that would yield use the law of sines. Will save you a lot of time here if you know that trick of the trade. Okay? So there's the law of sines and the type of challenges you will receive. Good luck. I know you will be able to rock and roll and see the sign that will open up your mind. Over and out.